Good afternoon. Welcome to this free session on Trigonometry grade 11 and 12. My name is Jeremy Brown. I am the Managing Director and founder of Brainshift Tutoring. In this session, we're going to have a look at the basics of trigonometry. This video is going to cover the scope of reduction. We're going to look at the fundamental trigonometric identities and how to go about solving such questions. Now, if you are in grade 11, this might be content that you have not yet covered. We will go through a brief revision of the grade 10 content covered, and then we will go into the grade 11 content. If you are in grade 12, this might serve as a revision for you. However, it is the basis of the fundamentals of trigonometry. Let's get into the lesson. Right, so as I've mentioned, my name is Jeremy Brown, and I'm the Managing Director and founder of Brainshift. Let's look at the content that we're going to be looking at today. So, we're going to start off by looking at a revision of grade 10 work. So this is basically where you introduce trigonometry. We're going to have a look at reduction and particularly focus on the cast diagram. It is fundamentally important that you understand how to make use of the cast diagram in order for you to be able to solve any reduction type questions. We're also going to be looking at negative angles, how to work with them, how to work with angles which are greater than 360 degrees should you be questioned in an exam to solve such questions. We are going to look at the fundamental identities, which is the square or the Pythagorean identity. We are also going to look at the quotient identity. Now, in grade 10, you were introduced to the very basics of trigonometry. In fact, when broken up, the word trigonometry basically refers to working with the shapes with three sides. So we're looking at triangles here. In other words, we are saying that most shapes in nature can be broken down into triangles, which can then be solved using the basics of trigonometry. Now, in grade 10, you were introduced to the theorem of Pythagoras, whereby in any right-angled triangle, we are able to calculate one side if we know the two sides. But just remember, take note of this. The theorem of Pythagoras only applies to right-angled triangles. In the event that you do not have a right triangle, then there are other techniques that you could use which are beyond the scope of this video. As we've mentioned before, all the triangles that you've worked with consisted of right-angled triangles. Say, for example, you're given a pentagon and asked to solve for one of the sides. You would then have to break down the pentagon into right-angled triangles, use the trigonometric identities or the trigonometric ratios, which we shall get into shortly, to find the missing side or the missing angle, or use the theorem of Pythagoras if you're given no angles, but only two sides. All of the angles that you've been working with in grade 10 have been less than 90 degrees. In other words, all of the angles that you were working with were acute angles. Now, the basic trigonometric identities, the basic trigonometric ratios that you were introduced to in grade 10, you were told that a sine of theta can be expressed as the opposite over the hypotenuse. Now, theta in this case, what we need to take note of is that theta is an acute angle. Theta is an angle which is less than 90 degrees. Meaning, if we have an angle which is greater than 90 degrees, we cannot use the sine trig ratio. We were also taught that a cos of theta can be expressed as the adjacent side over the hypotenuse. Once again, please take note that for sine and cos, we have the terms hypotenuse. The hypotenuse indicates the longer side of a right angle triangle, which is the side which is opposite the 90-degree angle. You were also taught that a tan of theta can be expressed as the opposite over the adjacent. Now, in some instances, you also worked with the Cartesian plane. And basically, since all angles are acute angles, all angles are less than 90 degrees, this would imply that when solving questions involving the Cartesian plane, you would only work in the first quadrant. Now, for angles in the first quadrant, the sine of theta would be expressed as y over r. Y in this case indicates the y coordinate of a point that we are given. R is the hypotenuse. Kindly take note of that. You were told that a cos of theta can be expressed as x over r, x being the x coordinate of the point that we're given, and once again, r is the hypotenuse. You were also taught that a tan of theta can be expressed as y over x, where both x and y are the x and y coordinates respectively of the point given. And then we have lastly Pythagoras' theorem, where we can express the hypotenuse squared as the sum of the x and the y values squared. Now, let's take a little bit of a breather. We're looking at reduction now. Now, what is reduction? Reduction is the process of reducing angles which are greater than 90 degrees. In essence, as we have said just now, for you to make use of the basic trigonometric ratios, all angles must be less than 90 degrees. This means if you sit with an angle which is greater than 90 degrees, you have a problem. Therefore, reduction is the process in which we can take any angle which is greater than 90 degrees and make it smaller than 90 degrees. We are taking any angle which is greater than 90 degrees and we are making it an acute angle. To understand the process of reduction, the first thing that you need to understand is what are the values, what are the signs of x, y, and r in each of the four quadrants. The first thing that you need to take note of is that r is always positive. The hypotenuse of any right angle triangle will always be positive. Let's proceed. Now, in the first quadrant, x is positive, y is also positive. In the second quadrant, x is negative, y is positive. In the third quadrant, x is negative, y is negative. Lastly, in the fourth quadrant, x is positive and y is negative. Now, in life, we have this thing called the cast diagram. We use the cast diagram for giving us the signs of each of the trigonometric expressions whenever we have angles greater than 90 degrees. Now, basically, to get an understanding of what the cast diagram is, we need to understand that clockwise direction is considered the negative direction in trigonometry, whereas the anti-clockwise direction is considered as the positive direction. On your right-hand side of the screen, you will see that we have this cast diagram. Basically, what you will see is that in the first quadrant, you have the A, which stands for all. And what does this mean? It means in the first quadrant, all of your trigonometric ratios are positive. In the second quadrant, only the sine trig ratio is positive. That implies that tan and cos is negative. In the third quadrant, tan is the only trig ratio that is positive. This means that sine and cos are negative. Lastly, in the fourth quadrant, only the cos trig ratio is positive. This implies that sine and tan are negative. An easy way to remember the order in which this diagram is to remember the mnemonic, all students take coffee, in that specific order. All being in the first quadrant, students standing for sine in the second quadrant. The third quadrant we have take, which is tan. The fourth quadrant we have cos, coffee. All students take coffee. This is an easy technique for you to remember how the cast diagram is structured. Now, how do we use this cast diagram? Let's have a look at it. On your screen right now, you would see that we've got three ratios that we can work with. We've got sine of 180 degrees minus theta, cos of 180 degrees minus theta, tan of 180 degrees minus theta. If we go back to the cast diagram, when we are starting at 180 degrees, we need to move in the negative direction because it says 180 minus theta. So basically what this means is the first value, 180, tells you where you need to start on the cast diagram. We are starting at 180 degrees. The sign is telling you which direction you need to go into. We're going into the negative direction, which we said the negative direction in trigonometry is in the clockwise direction. So from 180 degrees, if we go to the clockwise direction, we end up in the second quadrant. In the second quadrant, we only have sine, which is positive. So let's take a look at this. We're currently experiencing some difficulties with our system. Please do bear with us. But anyways, since we said we are in the second quadrant, that should imply that only sine is positive in the second quadrant. Therefore, a sine of 180 degrees minus theta is going to give us a positive sine of theta. If we have a cos of 180 degrees minus theta, let's just get this down. So a sine of 180 degrees gives us a positive sine of theta. A cos of 180 degrees, because this is in the second quadrant, cos is not present in the second quadrant, therefore this is negative cos of theta. Now, if we go to tan 180 degrees minus theta, that's in the second quadrant, sine is the only trig ratio which is positive, therefore a tan of 180 degrees gives us a negative tan of 180 degrees. Right, and this is how we would go about solving questions related to 180 degrees minus theta. Because 180 degrees minus theta is in the second quadrant, it means only sine is positive in the second quadrant. Cos and tan are negative. Now, when looking at sine 180 degrees plus theta, 180 degrees plus theta, we're moving in the positive direction, which is anti-clockwise. This takes us to the third quadrant. In the third quadrant, only tan is positive. Therefore, a sine of 180 degrees plus theta will give you negative sine of theta. A cos of 180 degrees minus plus theta will give us a negative cos of theta. This will give us a negative cos of theta. Then lastly, a tan of 180 degrees plus theta will give us a positive tan of theta. Moving right along. When we get to 360 degrees minus theta, this is going to take us, according to our cast diagram, 360 degrees minus theta, that would be in the fourth quadrant. Please pay attention, only cos is positive in the fourth quadrant. Therefore, sine of 360 degrees minus theta, this is going to give us a negative sine of theta. Cos of 360 degrees minus theta is going to give us a positive cos of theta. And finally, a tan of 360 degrees minus theta gives us a negative tan of theta. When we get to 360 degrees plus theta, according to our cast diagram, 360 degrees plus theta is in the first quadrant. Therefore, all of the trig ratios are positive in the first quadrant. So, sine of 360 degrees plus theta is a positive sine of theta. Cos of 360 degrees plus theta is a positive cos of theta. Tan of 360 degrees plus theta is a positive tan of theta. Now, please take note of something. Now that you understand the process of working with reduction, we can move on to two special cases when we're working with 90 degrees and 270 degrees. The important thing to remember here is that if we work with 90 and 270 degrees, sine changes to cos, cos changes to sine, tan changes to cot. Now, we are looking at 90 degrees minus theta. This is in the first quadrant. Therefore, sine of 90 degrees minus theta, sine changes to cos. Therefore, we have a positive cos of theta. Positive because in the first quadrant, all trig ratios are positive. If we look at cos of 90 degrees minus theta, because this is in the first quadrant, we're going to have a positive sine of theta. If we look at tan of 90 degrees minus theta, this is in the first quadrant, therefore it is going to be positive cot of theta. If we look at sine of 90 degrees minus theta, 90 degrees plus theta, this is going to take us to the second quadrant. In the second quadrant, only sine is positive. Therefore, sine of 90 degrees plus theta is going to give me a positive cos of theta. Cos of 90 degrees plus theta is going to give me negative sine of theta because cos is not present in the second quadrant. Lastly, a tan of 90 degrees plus theta is going to give me a negative cot of theta. When looking at 270 degrees minus theta, the process is the same. Sine of 270 degrees minus, in fact, if we look at 270 degrees minus theta, if we look at this in our cast diagram, we will see that 270 degrees minus theta is in the third quadrant. In the third quadrant, sine is negative, cos is negative, tan is positive. Therefore, we will have sine of 270 degrees minus theta gives us negative cos of 270 degrees. Negative cos of theta. A cos of 270 degrees plus theta, minus theta, is going to give us a negative sine of theta. Then a tan of 270 degrees minus theta is going to give us a positive cot of theta. If we're working with 270 degrees plus theta, according to the cast diagram, this is in the fourth quadrant. In the fourth quadrant, only cos is positive. So sine of 270 degrees plus theta is going to give us negative cos of theta. Just remember, when dealing with 270 and 90 degrees, the trig ratios have to change. Cos of 270 degrees plus theta, this is going to give us a positive sine of theta. Tan of 270 degrees plus theta is going to give us a negative cot of theta. Now, so far, we've been working with positive angles. In fact, even in your exams, even in your grade 10 exams, you are only working with positive angles. However, it is possible for us to also have negative angles. Now, remember we said that when we go in the clockwise direction, we're moving in the negative direction. Therefore, when an angle is negative, it always lies in the fourth quadrant. Please take note of this. We said according to our cast diagram, only cos is positive in the fourth quadrant. Therefore, this should tell us that a sine of negative theta will be a negative sine of theta. Why is this? Because sine is negative in the fourth quadrant. We said negative angles are in the fourth quadrant. Cos of negative theta will give us a positive cos of theta because cos is positive in the fourth quadrant. A tan of negative theta is going to give us a negative tan of theta. Now, whenever we work with angles which are greater than 360 degrees, we need to make it a point that we have to reduce more than once so as to get the angle to be an acute angle. For example, we have cos of 540 degrees plus x. When working with cos of 540 degrees plus x, we will have a scenario where we have a cos of 360 degrees plus. Now let's think for a moment. Which angle, when added to 360 degrees, gives us 540? That would be 180 degrees minus x. Please do forgive my terrible handwriting. Now, let's look at this. Cos of 360 plus will take us to the first quadrant. All of the trig ratios are positive in the first quadrant, therefore this will give us a positive cos of what? 180 degrees minus x. Now, 180 degrees minus x, this is in the first quadrant. Sorry, in the second quadrant. Cos is negative in the second quadrant, therefore we have a negative cos of x. So, what have we done here in essence? When looking at 540, we see that this is an angle which is greater than 360 degrees. If ever you have an angle which is greater than 360, you will always say 360 plus some angle, such that when added to 360 gives us the angle in question. 360 plus 180 gives us 540. Now, we have to break it down. First, work with 360 plus. We see this is in the first quadrant. In the first quadrant, cos is positive. Now we work with the remainder of the compound angle, which is 180 degrees minus x. This is in my second quadrant, where cos is negative. Here's a different example. In this case, we have a sine of 380 degrees plus x. So we can say this is equals to sine of 360 plus. Now let's think for a moment. Which angle do I add to 360 to get me 80? 380. The answer is 20. So this is going to be sine of 20 degrees minus x. Now once again, because we have an angle which is greater than 360, we have to reduce twice. So what's going to happen here is I'm going to have to break off the last part, the compound angle. And then I say, okay, a sine of 360 plus is in the first quadrant. In the first quadrant, all of my trig ratios are positive. Therefore, this is going to give me a positive sine of 20 degrees minus x. Now, please take note of something. If the angle that we have in question, like in this case 20 degrees, if this angle is not a multiple of 90, we do not reduce it. What do I mean? 90, 180, 270, 360, any multiples of 90, those are the only angles that we can reduce. Since we have a sine of 20 degrees minus x, we leave this as is as our final answer. Now, if you're watching this and you're in grade 12, you will be taught a technique on how to further simplify this. However, if you're in grade 11, this is sufficient. Please take note that the grade 12 working of this is beyond the scope of this lesson. Now, here's an interesting one. We have a tan of negative 390. Recall what we said. When working with negative angles, we are in the fourth quadrant. In the fourth quadrant, tan is negative. So I can write this as a negative tan of 390. Now, the angle is greater than 360. So I bring down the negative and I will say negative tan of 360 plus, which angle do I add to 360 to get 390? That's 30 degrees. Now, 360 plus takes us to the first quadrant. I bring this negative sign down. Tan is positive in the first quadrant, so I leave this as tan as it is, a tan of 30 degrees. So please take note, we're working with both a negative angle as well as reducing more than once. Because we have a negative angle, all negative angles are in the fourth quadrant, tan is negative in the fourth quadrant. Then because this angle that we have is greater than 360 degrees, we have to do some reduction. Now, let's look at this question here. This is a slightly different question because we have beta minus 180 degrees as opposed to 180 degrees minus beta. This is what we do. We can write this as cos of, I take out a negative sign here, then I write this as 180 degrees minus beta. So why are we doing this? Because we want to get the value of our angle, we want it to be before the variable. Now, looking at what we have here, we can see that we have cos of a negative angle. This is in the fourth quadrant. Cos is positive in the fourth quadrant, so this will just give me a positive cos of 180 degrees minus beta. Now, 180 degrees minus is in the second quadrant. Cos is negative in the second quadrant, so your answer is negative cos of beta. Sorry about that. Here's another example. We have the tan of phi minus 360 degrees. Now, for those of you who are unfamiliar, this is the Greek letter phi. It's pronounced phi and it's spelled P-H-I. So we have we have tan of phi minus 360 degrees. Once again, we can write this as a tan of negative, and then we write this as 360 minus phi. Now, tan of negative angle that's in the fourth quadrant, tan is negative in the fourth quadrant, so this is negative tan of 360 minus phi. Now, 360 minus is in the fourth quadrant, tan is negative in the fourth quadrant. But because we already have a negative sign here, the two negatives cancel one another out. You remain with a positive tan of phi. Okay, we have some more complex examples here. Now, these examples are beyond the scope of this lesson. But if you would like to receive the working to this example, just stick to the end of the video and I will give you some instructions on how to get the notes that we are currently broadcasting with, as well as solutions to the problems that we will not be covering in this video. Moving on to identities. There are two fundamental trigonometric identities that you will be introduced to in grade 11. Now, these two identities are the square or the Pythagorean identity, as well as the quotient identity. Now, the square or Pythagorean identity is written as cos squared theta plus sine squared theta equals to 1. Please keep this in mind. There is a technique on how to prove this, and it may be examinable if you're in grade 11. Excuse me. From this rule, we can conclude that cos squared theta is equals to 1 minus sine squared theta. We get that by taking the sine squared theta to the other side of the equal sign, it becomes negative, and hence we've got 1 minus sine squared theta. Again, if we can take the cos squared theta to the other side of the equal sign, we will then get an expression for sine squared theta, whereby sine squared theta is given as 1 minus cos squared theta. Next, we have the quotient identity. Now, the quotient identity is expressed as tan of theta is equals to a sine of theta minus a cos of theta. We've got a couple of questions here. Once again, these questions, the working shall not be covered during this video, but instead we leave it to you as homework questions for you to try out. And if you need the working to check whether your answers are correct, please just stick around to the end of the video and we will give you some instructions on how to go about obtaining the correct answers. This marks the end of our video. Thank you so much for watching. Thank you to everybody who has shared the link. Thank you to everybody who has participated in this video. Thank you to everybody who's been spreading the message, and thank you for everybody who's been joining us. Wherever you might be in South Africa or around the world, we thank you very much. Please do subscribe to our YouTube channel, and please hit the bell icon so that you can receive notifications whenever we have any new content on our YouTube channel. Other than that, you can visit us on www.brainshift.co.za. I repeat, www.brainshift.co.za. We hope that you found this lesson very intuitive. We hope that you enjoyed it, and we hope that you found it very beneficial towards your academic performance. Now, please do note that Brainshift is an academic institution which offers tutoring as well as exam revision content for learners in the FET phase. So that would be grades 10, 11, and 12. If you would like to receive the notes that we used during this broadcast, kindly head to live.brainshift.co.za. And if you have not yet done so, please complete the form and you will be emailed the notes. This video will remain on YouTube for the next 5 days after the commencement of this broadcast for you to have access to it. We sincerely do apologize that we could not broadcast as per the time that we had been allocated and the time that we have allocated to people, which was 4 o'clock. But unfortunately, due to some load shedding complications, we had to resort to issuing the video a little earlier on. I repeat, if you do wish to have the notes that we were using during the broadcast, you can go to live.brainshift.co.za and then you fill in the form there. You will be emailed the notes. The notes will be sent to you via email. Please do ensure that you have a working email address. For those of you who have already filled out the form, we will be automatically emailing you these notes after the broadcast so that you may have access to them whenever you need to study or whenever you need to go through revising what was happening during the lesson. If you do wish to receive the workings to the content that we have covered, you may also sign up at live.brainshift.co.za, or you can email us at info@brainshift.co.za. info@brainshift.co.za. Alternatively, if you need more information regarding our products, pricing, and services, you can contact us on the WhatsApp number 081 384 4567. That's 081 384 4567. We thank you for joining us during this broadcast. We hope it was a lovely session, and we do hope that you benefited from it. And to the matriculants of last year, the matriculants class of 2021, we wish you all the best with your future endeavors, with your plans, and may the Almighty One be with you and guide you through whatever your desires and wishes might be. To those of you who did not make it, do not hesitate, do not despair. A wise man once said, the word fail stands for first attempt in learning. Remember that the only person in life who has failed is the man that falls and does not want to get back up. Other than that, life is full of stumbling blocks. A year has 4 seasons. The cold season, which might seem like it's a very cruel time of your life. The wet season, which might be filled with tears and sorrow. You've got the sunny season in which it seems everything seems to be going well in your life. You have the windy season where it seems like you don't know which way to go. you don't have any direction. But take note of something. All of these seasons must come to pass for the year to be completed. However, it is the tears that you cry during the wet season that will serve as your source of water during the dry season. Ladies and gentlemen, boys and girls, thank you very much for joining. I am Jeremy Brown, and I do wish you all the best with your academic endeavors. Enjoy the rest of your afternoon. Please do adhere to COVID-19 protocols, stay safe, and keep studying.